Good morning, afternoon, or evening to everybody. This is Malcolm Hawker. I'm your host for the CDO Matters podcast. It is my distinct honor to be joined today by Chris Wiggins. Now, this is only a 30 to 40 minute podcast, so I think just going through your bio, Chris could consume a decent chunk of the time. But I will stay high level here. Chris is a associate professor at Columbia University in applied mathematics. Chris is a PhD from Princeton in mathematics. Yes. You are currently the chief data scientist at this publication known as the New York Times. Yes. And is the co-author of two books that have published within the last month. So this is a very, very busy gentleman. One of those books is How Data Happened, a history from How Data Happened, a history from the age of reason to the age of algorithms. We're going to talk about that book in more depth today because I'm excited to go into details of some of the things that Chris and his co-author shared in that fantastic book. But the other book is Data Science in Context: Foundations, Challenges, and Opportunities, also that he co-wrote. So that's a lot to chew on from a intro perspective. I was introduced to Chris by one of the smartest dudes that I know, Mr. Jeff Jonas, the CEO of Sensing, and now I know why. Because of the connection there, probably from a mathematics perspective. There are other connections, but I was honored to meet your acquaintance. And with that, Chris, welcome to the podcast.
Thanks for having me, Malcolm. Thanks for making time.
Wonderful. It's my honor, and I know that our guests will find all this interesting. So let's dive into the book of How Data Happened. I found it a fascinating read for a lot of different reasons, but being kind of enmeshed, day in and day out in the data world, I think it's easy to lose track of how we kind of got to where we are. So I found that interesting. I'm kind of a natural historian. I found a lot of that interesting, but I think a lot of the data people see kind of data being a synonym with truth. Right. And you can challenge that assertion if you'd like, but at the beginning of your book, a lot of what you share is actually how data was being used going back 100, 150 years in pretty nefarious ways to forward some pretty horrible social concepts. So what can you share about how kind of data was maybe perverted away from the idea of truth, if to the degree that it ever was, towards some of these horrible things like eugenics and kind of social profiling and racially profiling and all these other things?
Yeah, so the book grew out of a class, and the class, I like to say, is a class about truth and power. Really, every class should be about truth and power. So this class was about data, but it was about like how data relates to what we think is true, how we decide what's true, and the role of data in power. So when it comes to truth, one of the stories of the book, or the perennial themes in the book, is the way that people feel like if you have numbers, then somehow a fact is more true. Like a qualitative fact somehow just doesn't have the rhetorical impact of something that has a statistic behind it or has big data behind it, one way or the other. So part of the goal of the book is to take anyone, whether you're a technologist or not, and try to understand the limits of that, the limits of the extent to which, just because you have data or even big data behind you, the extent to which that makes your argument true. Now, when it comes to power, a lot of what we do also is to try to situate historical examples that are going to resonate for people today, in which people who have a lot of data also have power. And sometimes that relates to truth, because sometimes when you have a lot of data, you can say what's true. But sometimes when you have a lot of data, you can say things like, well, I have the data so I can make this policy decision. And I know that this is the way we should enact some policy decision. So the way that ties into eugenics and all that is really around the time that making sense of data became mathematical, and it happened to coincide with like the end. Well, I shouldn't say the end of the British Empire, but basically the waning of the power of the Victorian Empire, and a lot of people were trying to think about how we can use statistics to try to improve the empire and make sure that things seemed great. And the way they did it, was to take advantage of the latest ideas of the day, which included statistics, but also evolution and Darwinian conceptions of evolution. So the person who really brings it all together is a guy named Sir Francis Galton, who if you're raised in certain ways, you'll know his history. If you're raised a statistician, you'll just know that he gave us regression and correlation, which is true. He made up the two words, correlation and regression. He also made up the word eugenics. So we tell that story in the book, in part, just because we feel like not telling the story would sort of be like a lie by omission. But I think the useful part about it is to say, even when you think you're doing something good for the species or for the society, you really need to think, is what I'm doing, am I the baddie? Am I doing something that's really ethical? And it's hard to do that when you're focused on the tech and how sweet the technology is, to take a step back and say, okay, well, in addition to this being a sweet piece of technology, how does this comport with respect for persons and informed consent? Or how does this comport with our own notions of justice or oppression or fairness and things like that? And I think within some people in the technical literature over the last couple of years, people looked at that in computer science and other fields, but the pace of data innovation is so fast, it can be very difficult if you're really optimizing for one thing, like moving fast, to also either save space or better to incorporate into your process some way in which you're also thinking about, does this respect people's right to informed consent, and does this give them does this comport with our norms around justice and fairness?
Well, one of the things that I was kind of struck by as a data person is applying math to some of those things, right? So you mentioned this tension, for lack of a better word, that would exist between these forces, right? Government forces and corporate forces and societal forces, and that's a key kind of connecting tissue throughout your book. But one of the things that you mentioned was, am I operating in a socially responsible way or an ethical way? And as a data person, I found myself in the book often asking, how do I measure that? Yeah. and maybe this will become a bit of a fractal here. I'm holding a mirror in front of a mirror, but is there a way to measure these things? Is this something that can actually be quantified, or is that a fool's errand? And we know ethics when we see ethics.
I think it's good to think about quantifying it, because it's part of managing, is to have some success metric that you're keeping track of. But it may not be as granular as we like, like click-through rate. That is something that is easy to quantify and you can watch it. Or let's say revenue, right? Or any Wall Street facing metric. Those metrics are by construction easy to quantify. Some of the things that a company might do in ethics might be more difficult to turn into a really granular quantification, but still be quantified. For example, how many of your models are launched and what fraction of those models go through an ethical audit or some sort of ethical review? That's an example of something you can turn into a success metric. It's not as granular as how many dollars do we bring in, but it is something that you can quantify as a success metric. Or, what fraction of people's hours do they spend on ethical review, which, depending on how you want to run your business, could be large or small. How many people do we have who have passed unethical training? I mean, there's plenty of ways that you can come up with a number. It's just that the numbers are not going to be as obvious as the numbers, for example, with units of US dollars on it. Again, if there's a Wall Street facing metric, that's usually something where it's pretty real clear to everybody why that's a number you want to track. So ethical metrics are possible. They're just usually not as granular and directly tied to shareholder value as you're used to.
So in your book, you transition away from some of the early stages of kind of the application of data into more modern times, at least within the last 100 years. And one of the things that you focus on was how government and military have been responsible for the advancement in a lot of the things that we know today as kind of modern data management or modern application of statistics and even artificial intelligence. I'm glad you included the Turing story. I think it would be difficult not to. Having watched, I forget the name of the movie. It was
Imitation Game.
Yeah, Cumberbatch was Turing. Exactly. I mean, a perfect Turing, right? Yeah. But some of the depth of the story there, I really appreciated, and how important that whole effort was towards kind of modern artificial intelligence. So can you kind of connect some of the dots there from your research and what you shared in your book, and from how we got to some of the kind of the Turing efforts to where we are in kind of the earlier stages of AI?
Yeah, exactly. So what I was just talking about in like eugenics and the Victorian Empire, that's basically part of part one of the book.
Yeah.
And part two of the book opens up with Bletchley Park and Alan Turing. So so it's not a story that was told for the first, like, I would say 50 years after World War II, in part because in the United Kingdom, state secrets were taken very seriously, and a lot of the knowledge of what was done in like the very first data science problem, like dealing computationally with messy streams of data, was really quite strongly classified until the 70s. But yeah, the story we tell in part two of the book is really the creation of computation around data. So arguably the very first programmable computer was the one at Bletchley Park called the Colossus, which was completely secret for the next like 40 years. And it was created for a data science problem, dealing with messy streams of real world data in order to break codes and to perform active cryptanalysis or code breaking. It was also immediately the creation of sort of an industrial scale of data. So immediately people realized, well, you could build special purpose hardware, but if you really want to break codes all day, every day, you're going to build rooms full of computers, and you're going to have to collaborate with industry. So like right away in the UK and the US, there was collaborations with industry around a data science problem, like as people were building the first digital computers. In the US, that mostly happens at Bell Labs, which goes on to really create data science. I mean, the mindset of making sense of messy streams of data on a computer, like Bell Labs was decades ahead of everybody else there, which, no surprise, is why Claude Shannon created the mathematical theory of cryptography, which the next year he declassified as the mathematical theory of information. So it's basically the birth of information theory. And a lot of what we know in data science was born from that tradition. Similarly, IBM benefited from, I mean, we would now call it the military industrial complex.
Right.
We weren't calling it in the day, but like a lot of the first computers and one of the co-organizers of the very first artificial intelligence workshop was from IBM. And they were building these machines largely for either the NSA or the organizations that would later become the NSA. And as they aged out and the NSA moved from the IBM 701 to the 704, for example, IBM was like, well, what are we going to do with these machines? And one of the things they did that was extremely attention-getting was acts of machine learning. So the very first, I don't know if it's the first time the phrase machine learning was used, it's kind of debated there, but if you look in dictionaries, they'll say the first time machine learning was used in this is this one paper from an IBM researcher for playing checkers. And it was a hugely successful demo in like 1956, and then a paper in 1959. And so there's really an intimate role between data and computing, but also data computing and this sort of secret history of military funding and martial concerns that were really driving the problem towards innovation.
One of the things that I found interesting was there was somewhere, and I hope you can help connect the dots here. There was a pivot away from what I would call kind of rules-based AI and machine learning. More, kind of like you could guess what the rules were, and if you could anticipate all the rules and what rules would humans use to make a decision, well, then you could create something that was artificially intelligent. But somewhere that kind of broke, where it went from kind of rules and heuristics driven to more pattern driven. What was That's that right. break away from, okay, we can model a human brain by figuring out what rules they use, to let's go to the data instead and let's figure out what the patterns are as a proxy for understanding human behavior.
So part of what I hope readers get from the book is a reassurance that if terms like artificial intelligence or even statistics seem confusing, it should be the way, because it should be confusing. Because terms like artificial intelligence in 1980 meant nothing like what artificial intelligence means in 2023. So part of that is to just look at the root causes, like the origin of these terms. So artificial intelligence as a term is born in 1955, and it was created by a mathematician because he wanted to get money for a study from what eventually was funded by the Rockefeller Foundation. So we funded this workshop, and it was him and other mathematicians who really set the tone for the first couple of decades of artificial intelligence, for how artificial intelligence should be achieved, right? So the phrase artificial intelligence doesn't tell you what method we're going to use. It's not like I tell you calculus, right?
Right.
It just tells you what the aspiration is. And for the first couple of decades, the people who really shaped that field were people who thought that we should get artificial intelligence the way that we think. And the way those people thought we think was in terms of schema and representations. And what should we get artificial intelligence to do? Well, we should get artificial intelligence to do the things that we think are the highest aspirations of human intellect, which are proving theorems, right? And other things that are like organizing a business or something like that. So a lot of the emphasis was not on things that we like consider AI now, like telling if a picture has a cat face or a dog face in it or something like that, which was a big business for artificial intelligence the last like 15 years, or like to automatically tag an image or something. That wasn't what people were going after in the AI community. And by the 80s, it became clear that like that was a lot of work, right? Even doing expert systems, which is a style of artificial intelligence from the 70s and 80s, required you to go interview an expert and then try to figure out how precisely they are doing what they're doing, and then program into a computer every single brutal rule that an expert uses. And a lot of cognitive science today is countering that. It's like, truth is, we don't exactly know why we do what we do. Sometimes people make a decision, and then later they'll try to come up with some explanation of why they made that decision. And there's a lot of ways in which that breaks. So the paradigm from the late 90s, and certainly from this century, this millennium, is instead to just take a bunch of data and then use the right mathematics to let the data speak. And that's what we now think of as the machine learning paradigm.
I want to press on that a little bit more,
Sure.
but since we're following kind of a chronology here, and I'm a Virgo, so I like to go in order.
Love it.
You touched on the 90s. Now you're barking right up my tree here with when I actually started to get involved professionally. And one of the things that I found very interesting was your detail around some of the early years of the internet, and what you kind of rightfully call the development of persuasion architectures, and how the whole birth of the internet, the commercialization of the internet, really kind of turned some of, I'll just kind of say turned a lot of the developments here from a data and ML and AI perspective into guessing what people would want and what they would do and how they would engage, which is particularly relevant in today's world. But going back to 1995 and 1996, when I started to get involved here, it was a wild west. There wasn't a lot of rules defined. One of the things that I found most striking in your book, which was absolutely positively bang on, was what you said. In essence, I'm paraphrasing you now, was that you said that the internet was largely born out of 26 words of the Communications Decency Act of 1996. That allowed internet service providers to avoid being deemed a publisher of information, and which is particularly relevant in a world of user-generated content now, where those publishers don't have a authority over what people are putting on their platform. But this happened in 1996, and it was formulative. Yeah. So how does that actually influence what we know today as the internet? Those 26 lines.
Yeah. So another aspect of the book, or we hope a use of the book, is to make the present strange, to make people look back and say, well, how many different things had to come together sort of accidentally in order to create what we now think of as normal, right? Because in 1996, the way we live with our relationship with information wasn't set yet as norms. And so a lot of things had to come together: norms, technology, markets, and law, right, and regulation. So 96, right? So Communications Decency Act of 1996 was an attempt to make sure that the internet was only sharing decent content, which you can imagine a lot of people wanted to support at the time. Who could be against decent content? But they had a carve out that was inserted into the act, which was these 26 words, now called Section 230, which say that if you're just the pipes and you're just transmitting information from one place to another, you shouldn't be responsible for what the content is. And you're right that it would have a complete chilling effect on our whole, well, if not the whole economy, certainly the tech economy, right? We've got $1 trillion companies which are benefiting from the fact that like they don't have to do any moderation of the content other than a couple of protected types of content, right? So there's like copyright violations, like porn and like other
slander and libel,
right? Exactly, yeah. So certainly in the case of newspapers also, which have extra regulations associated with them, right? So there's a couple of things there. One, we all like the First Amendment, but that said, that like we all know that there actually are limits on the things you can transmit. For example, the protected classes we just enumerated. And as you just got at, if you're a publisher, then there's extra things that you have to pay attention to, right? And so that's why it's very important. If you are just the pipes that are transmitting the information, you do not want to be classified as a publisher, because then you will be regulated according to those things. So I guess another thing we hope people pick up out of the book is that it didn't have to be that way at all. And even the way we do regulation in the States is so sector by sector, right? Unlike European regulations, which will just apply to technology horizontally across different sectors, we've done things over the last 100 years where like finance is regulated in a different way than publishing, which is regulated in a different way than something else. But yeah, by looking at these pivotal elements like the 1996 CDA, right, we sort of see how things could have been different.
So I was there at Ground Zero. I worked for this internet startup called AOL from 95 to 2005. And the issue of, are we a publisher or are we a common carrier, right? Are we basically an AT&T, right? This was forefront with a lot of what we were kind of trying to figure out at the time. And those 26 words really kind of galvanized, we're not going to be held responsible for our users saying libelous things or slanderous things, because that's their responsibility. If you do something dumb online, it falls to you. It doesn't fall to me as the internet service provider. Right? And I think one could argue that alone was what kind of was the jet fuel to allow the internet to become what it is today. Because otherwise, I think it would have been taken a lot longer to get to where we are. So I was just so pleased that you touched on that in the book. It was fantastic. But there is kind of a tie back here to today's world and AI, and particularly the use of data, which may or may not be in the public domain, to train AI models. So, what are your perspectives on the issue of copyright as it relates today? Now, we can. It's easy to pick on ChatGPT because a lot of people have played with it, and a lot of kids are using it to do their homework. Do you see there being any sort of regulatory focus there eventually? And I'll tell this through a kind of an anecdote. I've asked, of course, like many, I've asked ChatGPT a lot of questions, and I asked it questions that I used to get as a Gartner analyst. And the answers that I got back, Chris, I could have swore I wrote them. I could have swore that the content I was reading,
maybe you did.
Yeah, the content that I was reading,
something you wrote.
Yeah, and the content that I was reading had come from something that I had assumed was copyright. Do you see there being any sort of regulatory issues that will come up? I mean, I know that on image front, like Getty is suing, for that's a layup, right? When you've got the watermark.
That's exactly right. That is a layup. That's
I mean, that's a layup. But like, do you see any sort of kind of conflict erupting here between copyright and what's happening in the AI world now?
Yeah, it's so hard to predict the future. But the thing about the Getty one is really good though, because you literally can see it, right? The copyright violation is something you can see in your eyes, the image and the watermark, and you can see it in the synthetic images. So it's harder to see it in the form of content, like an article. Unless you ask it to quote something, in which case, which is also kind of fun, like asking it to quote some document or something like that. It'll come up, particularly in things like first thing I did with Bard when I got access to Bard was I asked it, okay, what's on the, because unlike ChatGPT, Bard is not, it doesn't say it in front. Okay, what all the content is from 2001 or 2021 or earlier. So I said to Bard, okay, well, what is on the front page of the New York Times today? And it gave me a list of the top stories in the New York Times today. And I said to Bard, doesn't that violate the licensing agreement you have with the New York Times? And it said, I'm sorry, I violated the licensing agreement with the New York Times, which was nice of it to say it. Sorry, but yeah, that's an example where you can sort of just follow the logic, and you can see.
But technically, I'm not human, so actually, no, I didn't, because copyright only transfers to human beings. It doesn't actually transfer to a machine.
Right. So that's going to be an issue for lawyers to work out, and it's a good example of the timescales, right? I said earlier that things are changed by, markets and laws and technology and our own norms, and each one of those things has its own timescale. So technology clearly moves fast, And then our norms sort of catch up, and we're like, well, it's a little uncool to send somebody a death notice that was written by ChatGPT. That's like a statement about how our norms catch up. Law and marketplaces then catch up, where people are like, okay, I'm going to sell access to ChatGPT, and then eventually laws catch up, right? So each one of those forces is real, but they all have a different time scale associated with them. So it's going to take a while for the laws to catch up. And I don't know that I can make a prediction for how that's going to go down. Getty, I think, is like we said, it's obvious. You can see it with your eyeballs, and everybody's going to support some sort of regulation that protects that. But for things that are like content, it's literally harder to see, right? The even plagiarism detection is done statistically usually. Those, I don't know how they're going to be fought between, it's not like publishers have like a big lobby behind them the way tech does.
Right.
So
Right.
I'm not really sure how that fight is going to go down.
Well, it reminds me a lot of the early days of kind of the recording industry versus the internet, right? And peer-to-peer sharing of copyrighted recorded music, and how that kind of shook out, and that enabled the creation of digital rights management, which I would argue is in many cases a blatant violation of first use doctrine, but separate issue. So before we transition away from the book and AI and data, one of the things that you were talking about also kind of reminded me recently. I was watching Sam Altman on Lex Friedman's podcast. I don't know if you caught that or not.
A student in my class said I should watch it, but I haven't.
Yeah,
watched
you should. It's a good conversation. For those who don't know, so Sam Altman is kind of like one of the founders of OpenAI. And arguably kind of one of the driving forces, obviously not the technical driving forces. There's many brilliant engineers that are behind it, but he's kind of the spokesperson, as it were, for OpenAI and ChatGPT. And he was asked recently by Lex Friedman if Sam Altman thought that ChatGPT 4 was generalized artificial intelligence. So what does that mean to you, Chris? And what's relevant there? I can give my perspective, but you're the expert, not me.
Sure. Let me give a technical definition, and then let me give sort of my take on it, or the lesson that I've learned from the literature. So the technical aspect there is, in early days, you can look. I always like to look at primary documents. So in 1955, when McCarthy was proposing to the Rockefeller Foundation that he have a workshop on artificial intelligence, he said the workshop will be dedicated to the hypothesis that all aspects of intelligence can be so precisely described that it can be programmed. So in the original incarnation of the phrase artificial intelligence, that was a pretty lofty goal, right? Every aspect of human intelligence can be so precisely described that you can program it. And what was in scope there was every aspect of human intelligence, however you want to define it. Over the years, you get this separate community, which we don't talk about very much anymore. At the time, in the 50s, it was called the pattern recognition community. It was a much smaller community, which was looking at things like, I hand you a picture, and you tell me whether or not there's a tank in that picture. Now, I choose that example because this was also largely funded by military concerns. So pattern recognition is this small community doing what we would now call discriminative learning, or building a binary classifier from image data. And that community built the methods that eventually became rechristened as machine learning, and those methods work, right? And so for a large part of this millennium, the applications that were driving a lot of the innovation were things like multi-class classification and high-dimensional problems. So you take like an image where the features are every single pixel, and you classify it as being one of the 10 digits, for example. That was a test case that really drove a lot of innovation. Or you classify it as being cat face or dog face, or you tag images within those images. Those are all things that worked, but they are not general artificial intelligence. So people started using the words strong and weak AI, and then they started using the word general and narrow AI to refer to the ideas that some of the AI we're doing is like hot dog versus not hot dog. It may work really well, but it's kind of narrow, small bore problem. It's great on the way towards, but what we really want is general artificial intelligence, something that can emulate any aspect of human intelligence. That's clearly a grand goal. And to be clear, like, I don't know that many people who would say that we've reached anything that is actually general artificial intelligence, although I haven't listened to that podcast yet. So I don't know how Sam answered the question. In any event, before you tell me, let me tell you what lesson I've learned from the literature. For around the same time, when we mentioned Alan Turing earlier, so Alan Turing shows up in 2 subsequent chapters. He shows up in the chapter on Bletchley Park, of course, because he's famous, among other things, for code breaking, but in the very next chapter about the birth of artificial intelligence. And he writes this paper in 1950 saying, we would like to investigate if machines can think. And right away he says, that's a bad question. I'm going to replace it with the better question, can I build the following imitation game? So right away he operationalizes it. And often when I hear people debate whether or not we have machines that are intelligent or they have cognition or they're self-aware, I just think, like, we're not going to come to consensus. Let's just agree to a couple of benchmark tasks and operationalize it. And then we have at least something concrete we can talk about. So you can ask questions like, can ChatGPT-4 pass the bar exam? Which, by the way, it can.
It has, yep.
Yeah. So that's an operationalization, and we can talk about that in a much more concrete term than whether or not it's intelligent, which I find a little poetic. I only have a couple of years left on this planet. I don't want to spend that much time thinking about whether something is or not really intelligent. So with that preamble, so what did Sam say?
Well, he said no.
Okay.
It's not general artificial intelligence, which I think, at least for me, for kind of not as smart people, for me means kind of logic and not logic, reason, rationale, plus creativity, plus innovation, coming up with novel solutions that have not previously existed, that one couldn't necessarily have patterned or predicted. Mm-hmm. I don't know if that's useful, but that's kind of how I think of it anyway. When I think of kind of just pure pattern recognition, one of the things that I'm slightly maybe worried about, and I love your perspective on this, is that kind of, and again, this is maybe an overly pedestrian way of looking at the world, but if you're always looking at previous data, to me, the metaphor here is like, I don't know if you've ever driven a boat, but if you're looking backwards and you're driving a boat, you can drive a boat off the wake. You can drive it in a straight line. But if you try to deviate from that, if you want to deviate from that straight line, you're going to be in for some trouble, right? So if you're only looking back, how do you, based only on previous data, where does the world of kind of true innovation and creative thought live in an AI-driven world? Do you know what I'm asking? Where does true creativity come from if I'm only looking back?
Yeah. So this shows up in a lot of technical literatures. For statisticians, sometimes they talk about the difference between extrapolation and interpolation. So you can imagine it just in a curve, right? And if I hand you a curve and the curve has some finite extent, it's a lot easier to interpolate, like between the points that you have as training data, than it is to extrapolate to some regime you've never seen before. So that's a statistical view. A different statistical view, which is related to natural sciences, but also economics and policy, is the literature around causality. So causality is one whole literature that gets at what you're getting at. So like in the book, for example, we talk about when people started using statistics for policy. I think this is chapter 4. One of the first things that happened was somebody looked at how many poor people there were in every region of England and how many people were receiving assistance from welfare and how many people were receiving assistance in a poorhouse. And there's a positive correlation between how many people are receiving assistance and how many people there are getting welfare, or how many poor people there are. And the author of that experiment or that analysis concluded that because those are positively correlated, then giving people help must be causing poverty. So that's an example of correlation and causation and how they can be conflated. It's a good example because the title of the paper was On the Causes of Pauperism. And then in footnote number 25 in that paper, he says, strictly speaking, you should read this as is associated with, not necessarily causes. So that's an example because you do not know what would happen in a world in which you doubled how many people got welfare or how many people, just stopped giving welfare in that particular region. So you can predict things in this world from this one distribution, but it doesn't necessarily give you a causal model of what would happen in a world in which you had done something that you had never done before. And then this shows up all the time when people look at the limits of statistical modeling, right? If you have data, right, but the data are drawn from a limited set of experiments, you really don't know what would happen in a world in which you introduce an innovation that's never been done before. So that's a real challenge, and it's an example of the kind of thing that we should remember to have some humility about what we can do with statistical modeling. We can do a great job predicting other data that are similar to the data on which we've trained the model, but often we cannot make any predictions for what would happen in a world in which we break how different observables are related to each other.
Strong argument for a little bit of chaos in our future. So that's a great way to segue away from purely talking about the book. But I would most certainly, I found it a fascinating read, would most certainly recommend How Data Happened by Chris Wiggins for any chief data officer out there, particularly if you want to kind of extract yourself away from some of the day-to-day and talk about and think about some bigger picture issues that most certainly are relevant to what you do day in and day out. Let's segue into the kind of the doing day in and day out. You are the chief data scientist at the New York Times.
It's true.
I recently had some conversations with a number of CDOs and CIOs who all shared with me, there's about 30 of them. We were having a kind of a workshop around recruitment and training and retaining data-related talent. And a lot of them shared with me that they felt like the title of data scientist was kind of falling out of favor, and that may be in and of itself overly lofty, and that so many of them were kind of now aiming towards more kind of utility players and more kind of data engineer types. Are you seeing the same? You've got a data scientist role. What do you think about that?
So what I've seen is things get more granular. So a good, so one of the things that I know I should leave the book, but one of the things we talk about in the book is there's this paragraph from Jeff Hammerbacher, which he wrote in 2008 or 2009, saying what they did in the data science team at Facebook. And he said data scientists could be building a multi-stage processing pipeline, building a data-intensive product in Hadoop, doing a statistical analysis in R, and explaining the results to the rest of the organization in a clear and concise fashion. So many of those things have now gotten separate job titles. So like statistical testing at the New York Times largely is done by a group around experimentation and involves a lot of the data analysts. Making sure that people mean the same thing when they talk about like subscription start and stops. That's a group in data governance. Building a multi-stage processing pipeline, we have a group now called data engineering. And the data scientists are focused on developing and deploying machine learning. So I think a lot of it is that the sort of unicorn-like aspect of the job title in 2008 has now gotten more granular as people realize, oh, actually each one of those is a separate skill set. I should say we also try to hire for people that I feel comfortable having them explain to the rest of the organization in a clear and concise fashion what we're doing. So there's been some refinement as people realize that it's not just sort of all an amorphous blob of data science, but there's actually separate skills there, and like building a really good data team involves having people who play different roles, just like any other team. You don't have like everybody playing shortstop. So, everybody is playing distinct roles, and companies are realizing how those roles play well together.
Got it. And I was interested, I found the quote from Facebook, the gentleman's name, Jeff, and I will probably mispronounce his last name,
Hammerbacher, yeah.
Hammerbacher. Well, I'm a fan of the All In podcast, and I don't know if you've ever watched that, but one of the people there is Chamath Palihapitiya, who I worked with at AOL. Wouldn't be able to pick me out of a crowd, but I worked with him at AOL, and he went to Facebook, and I could have swore that he said that he came up with the data scientist title.
He should definitely publicize that, because most people attribute it to DJ Patel and to Jeff Hammerbacher.
He was at Facebook, so maybe he was just in the room. I don't know. Our time is winding up here. One other thing that I wanted to kind of to tie off on was how data science is being leveraged at the New York Times. So describe for me the output of your work. How would that typically be leveraged within arguably the best known newspaper on the planet?
Sure. So I showed up in 2013, and since then we've built out a lot of functions in which data science can be helpful. So one is recommendation engines. So both recommending content in general and also personalizing content. Those are done through machine learning algorithms. Another is building a better paywall. So the New York Times, has transitioned over the last 20 years from a advertising-based model to a subscription-based model. And in particular, a digital subscription model is really where the company sees its future, which means you need to have some sort of differentiated experience between free and pay. So the sort of blunt instrument there is a paywall, which when it was launched in 2011, I think the logic there was you get 10 articles a month free and that's it. And then you have to pay. So we're now much more granular about that and have a lot more flexibility. And so that's a machine learning model that determines when is the appropriate moment for a person to put up a paywall. And in fact, that's something that you can optimize and tune between, are you trying to optimize between engagement or short-term subscriptions, where engagement is sort of a proxy for long-term subscriptions. If you believe that people experiencing the breadth of the content will someday make them want to become a paid subscriber. We have some innovative ad products that we've created in part to get away from surveillance capitalism. So to get away from the idea that you put a tracking pixel on every page that goes to a third-party data broker, and then data broker says to you, I think this person is a soccer dad or NASCAR mom or something. So we've built our own innovative ad products that are much more around contextual targeting. For example, deep sentiment analysis that can say to marketers, this is an article that we think will make people feel excited or hopeful. And then marketers can decide if they want to advertise next to that sort of contextual advertising. Those are all done by my team. Bunch of other stuff, some stuff we've discussed publicly, sometimes stuff not, but there's a lot of things that we can do to improve efficiency and to drive up important KPIs to keep the company strong and independent.
Good stuff. I'm going back to the book because I'm struck by one of the quotes, and I'm going to quote it word for word here. One of the things you said, I don't know if it was you or your co-author, but the quote is, what does it mean that our primary source of truth delivered to us in the palm of our hands is funded by and optimized for the surveillance ad model? That's something that really, really struck and stuck with me, particularly when I look at some of the business models that are out there today. And I guess our last question is, do you see a world where some of the business models, whether it's traditional media, whether it's the internet, whatever, doesn't matter. Do you see a world where we break away from some of these, what you call the kind of the surveillance ad model, or just advertising driven writ large, where we're able to break away from that into other business models?
Sure. So, I mean, I have a bias here working at New York Times, but one obvious alternative is subscription models.
Right.
Right. So you want to keep a company in business, right? Spotify, Netflix, there's plenty of companies that are doing well with the subscription dominant rather than an advertising ad model. By the way, let me come back to 1996, right?
Yeah.
So so Section 230 made it possible for tech companies not to worry about what the content was, and that made possible user-generated content as the dominant source of content. Now that's great for driving engagement, but you need to make it easy for anybody to use your site, which means you don't want a subscription model. You want a free model or advertising model. It also means that you're going to have so much content that you need some algorithm that's going to determine for this person which is the right user-generated content from some other rando on the internet to show that person, which means you need machine learning. So looking back at the last 30, 40 years, you can see in retrospect how all these things had to come together. Technical decisions, economic decisions, our own norms. The fact that people are like, yeah, advertising, I just expect that to be there. I don't want to have to pay for content. But I think what you're seeing a lot in the last decade is people saying, well, maybe some content actually is worth paying for, rather than having like the information assault of a bazillion pieces of user-generated content in order to find the one that's actually useful to me. Right?
And that was the heart of my question, because getting back to the previous questions about AOL and the 26 words that founded the internet, or that helped fuel the internet.
Yeah.
I think you're absolutely right. There's this underlying kind of assumption out there, writ large, whatever that means, that, well, it has to be advertising and this is the way it is. It's always been this way. And when we get into conversations about kind of misinformation, what's truth, what's not truth, about persuasion, about people living in these bubbles where they're only ever fed the same ideas and the same concepts and all the rest, that is largely a function of the business model. But there are other models out there, and I'm optimistic that chief data officers will figure this out, whether they work in media companies or whether they work somewhere else, because there are other worlds out there. I think there is a world for curated content. I think there is a world for authors and innovation and creation when it comes to online content. We may not be seeing it today, but it didn't always have to be this way. Great way to tie off the conversation. Chris Wiggins, thank you so much. It's my honor to talk to you. So glad that Jeff connected us. I could keep going for hours and hours. Again, totally recommend the book. It's available on Amazon now. It wasn't about a month ago. When did you release?
A couple Tuesday weeks? Last week. So it's only been 8 days.
All right. Fresh, hot off the presses. Congratulations on the book.
Thanks so much.
It's a fascinating read. Thank you so much for spending time with us today.
Thanks, Malcolm. Appreciate it.
Bye-bye.